Hope you all are doing good. I am Anjana from Learnohub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 9 Physics Chapter 5, Upthrust in Fluids, Archimedes Principle and Floatation. First, we will be discussing Upthrust and Archimedes Principle with examples and solve questions from exercise 5A. Are you ready for the session? Let's begin. What is buoyancy or upthrust? We'll start with an experiment. So here I have taken a glass of water and I have two objects in my hands, a stone and a pen cap. Okay, I'm going to put this objects inside water. Let's see what happens. So first I'm dropping the stone inside water. You can see that the stone has gone to the bottom portion of the glass. That is, the stone has sinked. Okay, now I have a cap, a pen cap. I'm going to put it inside the water. So you'll be able to see that the pen cap will be floating on the surface. It won't sink. So why is this happening? One object has sinked and the other object is floating. So what is the reason? There is some force that is holding this object on the surface of water. Okay. So here we know that every object is experiencing gravity. Gravity will act down in the downward direction, that is, weight of the body will be acting in the downward direction. So here in this case, the cap will be able to float on the surface of water because there is some other force which is greater than gravity that is holding it there. So some upward force is acting on this object. Okay, this upward force is called the buoyancy or the upthrust. Okay, so we can define buoyancy as the upward force exerted on a body by the fluid in which it is submerged is called the upthrust or buoyancy. Upthrust or buoyancy, it is represented by FB. Okay, and the unit is, this is a force, but therefore the unit of upthrust or buoyancy is nothing but newtons. Okay, so here you will be able to see that two bodies, one body is floating, the other body is sinking. So what is the reason? The buoyant force is acting in the upward direction. Here the weight is greater. Here the weight compared to the buoyant force is less. And so the body will float. So got a brief idea about what buoyancy is? Pushing an empty can into water. What happens when you push an empty can into water? So to understand this, we'll again start with the same experiment. So here I have a glass of water and the same cap I am using. When I put the cap on the surface of water, what is happening? It will float on the surface of water. Now what I am going to do is I am going to apply a force, that is, I am applying an external force. So when I apply an external force, the body is moving downward. I will be experiencing a force that is acting in the upward direction. So I will have difficulty to push it downwards. Okay, once I release it, that is, once I withdraw the external force, what happens? The body will come back to its original position. So if I need to maintain it at this position, I should continuously keep applying the force. Once the force is removed, it will come back to its position. Okay, so here you can see what is happening. Upward force and the downward force are acting. The upward force is greater, which brings it to the surface of water. Now you take the case of this can. Okay, the empty can, it is closed with an airtight stopper. When a force is applied, that is, when you are pushing it downwards, what happens? It will go inside water. Okay, it will go inside water and reach a point. Once you remove the force, that is, once you release it, what happens? It will jump up. Okay, it will come back to its original state. So in this case of a can, only a small portion of this will be inside water. The remaining portion will be on the surface of water. Okay, so this is a case. So here we have understood that the upward force acting on the body is greater than the downward force, that is the gravity. Buoyant force is greater than gravity in this case. Next is, if you are taking the case of a cork, okay, a glass of water is taken and a cork is placed. When a cork is placed, about 2/5 of the cork will be inside water. Okay, 2/5 will be inside water and 3/5 will be outside water. So here again, this is the same as the case we have discussed before. When the can is placed, what is happening? It is sinking. It is floating. Okay. Now when you apply a force is applied. I want to bring it to this point. I want to keep the object at this point. Is it possible? When force is applied, once the force is removed, what happens? It will come back to its original position. Okay, if I need to keep it here itself, what should be done? The force should be exerted continuously. Okay, here both the forces are there, that is the weight is acting downwards and upthrust is acting upwards. The maximum upthrust is represented by FB dash. FB dash is the maximum upthrust. In this case, we have understood upthrust is greater than the weight of the object. Okay. Now, the external force that is applied in order to maintain it at this position will be equal to the FB dash minus weight. This much of external force is required to maintain it at this position. Okay. Understood? So, this is a case when you take a cork and place it on the surface of water. Now we said that in liquids, a body which is immersed in a liquid will be experiencing a force which is a buoyant force. Apart from gravity, there is another force which is the buoyant force or upward thrust. Okay. Now, this is not only the case with liquids. When you consider air is a fluid, right? So, if a body is in air, is there this buoyant force or the upthrust? Yes, here also the buoyant force or the upthrust is present. We know that this is an upward force. It will be acting in this way. Okay, this is why in a liquid, when a cork is immersed, what happens? There is the upward force. Okay, so because of this upward force, the body can float on the surface of water. But now you can see that I can stand on this floor. If there was the upthrust, will I be able to stand? No, right? Because of upthrust, I should move upward. Here, I am not moving upward. I am able to stand on this floor. Only gravity is acting on me. No. Here, it is not just gravity, but the buoyant force is also acting. But the reason is that buoyant force is negligibly small. Okay, here the upthrust or the buoyant force compared to gravity is negligibly small. So, you cannot have the effect of upthrust. Okay, still upthrust and the buoyant force is present. We won't experience this upthrust or buoyant force just because gravity is very greater than the upthrust or the buoyant force. Okay, like liquids, gases also have the property of buoyancy. That is, a body immersed in a gas also experiences an upthrust. All objects, including ourselves, are also acted upon by a buoyant force due to air, but we do not feel it because it is negligible as compared to our own weight. Comparing to our weight, this buoyant force is negligible. Have you heard of hydrogen balloon? You know, right? If you leave the hydrogen balloon, what happens? If you are not holding the hydrogen balloon, the hydrogen balloon which was in your hand, you are just releasing it. What happens? You will be able to see that the hydrogen balloon will start rising up. Okay. What about the normal balloon? Once released, it will fall to the ground. So, here in a normal balloon, it is just the air. Okay. We are filling with our air inside it. But when it comes to the case of hydrogen balloon, it is the hydrogen gas. Hydrogen gas that is being filled inside the balloon. Okay. Now, when you compare it with normal air, the density of hydrogen gas is very less than the density of air. Okay. A balloon filled with hydrogen or any gas less denser than air rises up. Okay. This is the reason why the hydrogen balloon rises up. Because on comparing it with air, its density is less. Okay. When density becomes less, what happens? We have weight and the upward force or upthrust or the buoyancy. Okay, both these will be acting. Now here what has happened? Comparing to the weight, the buoyant force or the upthrust has become greater. Due to this reason, it rises up. Okay, conditions for a body to float or sink in a fluid. So we know that here you can see a body that is immersed in a fluid. Two forces will be acting. Which is the first force? First force is the weight. Okay, weight is the force which is acting vertically downwards. Okay, there is another force which is the upthrust. Upthrust, in which direction will it be acting? It is acting upward. Okay, now you can see that this body is in such a state. Here we have the free surface. The top end of the body is coinciding with the free surface of the liquid. Okay. The body can be like this. The body can be like this. The body can be like this. The body can be like this, or the body can be like this. All these are possible, right? All these options are possible. Okay, that is the bottom end of the body is in touch with the, is touching the, or is coinciding with the free surface. Okay, here what is the case? Here 1/3 is inside the fluid and 2/3 is outside. Okay, here 1/3 is outside, 2/3 is inside. In this case, 1/4 is outside and 3/4 is inside. Okay, now in this case you can see that whole of the body is inside the fluid. Okay, all these cases are possible. Now when does these happens? That we'll be discussing. Okay, so two forces are acting, one is weight and one is upthrust. So the difference in weight and upthrust will make these changes. We know that different fluids will be having different densities. So depending on the densities, okay, the weight of the body can be less than the buoyant force, which is represented by Fb dash, or the weight of the body can be equal to the buoyant force, or weight of the body can be greater than the buoyant force. Okay, now you are able to see that an object is placed here. Okay, in this case, the object's top portion and the free surface of the liquid is coinciding. Okay, now other possibilities are this way the object can be, this way the object can be, this way the object can be, this way the object can be. All these are possible, right? So when weight of the object becomes equal to the buoyant force or upward thrust, this is how it will be. Okay, that is a top, that the body gets completely immersed in the water and it is floating. Okay, so first case is when weight and Fb dash, weight and the upthrust or the buoyant force becomes equal, the body will float with whole of it immersed in water. Okay, in all these ways the body can float. Okay, now here in this case you will be able to see that the net force will be equal to 0 because weight and Fb dash are equal. Okay, now Fb dash or the maximum upthrust, when does it happen? Okay, this is the case. Next is, you can see the body. Okay, these are the different possibles. Okay, now when Fb dash is greater than W, what does it mean? Upthrust is greater than W. This is the second case when the body will float. Okay, all these comes under this. Okay, here this is a case when there is maximum upthrust. Here upthrust is greater than W. Here again upthrust is greater than W. Here also upthrust is greater than W. Here also upthrust is greater than W. Okay, the value of upthrust will be maximum in this case. It is reducing. It reduces and becomes equal to the weight of the body. It's when the body is completely immersed in the liquid and it is able to float. Okay, so this is the first thing. If Fb dash is greater than W or Fb dash is equal to W, the body will float, it will not sink. Next is the case when body sinks. Okay, body sinks when the upward force is less than the weight of the body. Okay, so here the body will be experiencing a net force. Here the net force experienced by the body will be equal to weight of the body minus Fb dash. Okay, weight of the body minus Fb dash. So here this body which is put into water will be moving down because the weight is greater, weight is acting downward. Okay, so when it is moving down, we'll know that the mass of the body is m. Okay, it will be moving down with an acceleration a, m into a. This mass into acceleration will be equal to the net force. Here the net force is weight minus Fb dash. Okay, from this we can find what the acceleration is. Acceleration will be equal to weight minus Fb dash divided by mass. Okay, this is how we can find the acceleration with which the body is moving down. Okay, this is possible. That is, here we are neglecting the viscous force. The liquids will be having a viscous force. Here the viscous force is neglected. In that case, acceleration will be equal to W minus Fb dash divided by m. Okay, so here the body will not float, it will sink. Okay, it will come from with the body which is put into the liquid will come down with an acceleration equal to W minus FB dash divided by M. By now we have understood what is upthrust. Now we will be discussing the characteristic properties of upthrust. Okay, so the upthrust has the following three characteristic property. First one, larger the volume of a body submerged in a fluid, greater is the upthrust. Second, for the same volume of a body inside a fluid, more the density of fluid, greater is the upthrust. And the third, the upthrust acts on the body in upward direction at the center of buoyancy, that is the center of gravity of the displaced fluid. Okay, now we'll be discussing these in detail. First one is, larger the volume of a body submerged in a fluid, greater is the upthrust. So here you can see two objects. Okay, first is a cork, another object is there. This has completely sink in the water. Okay, what does it mean? Here the upthrust is very less compared to the weight of the body. Okay, FB dash less than the weight of the body. Now what about this case? Here it is the case when FB dash is greater than the weight of the body. Okay, now there will be having different cases. Okay, the body can be in this way, the body can be in this way, or the body can be in this way. There are many ways possible. Okay, now here you can see the volume of the body immersed in water is 0. Okay, it is just floating. Now here this much portion is immersed in water. Here this much portion is immersed in water. So what do you understand? The volume is changing. Okay, the volume is increasing. Volume of the body that is submerged in the liquid, in the fluid, is increasing. So what happens when you try to, the first experiment that we performed, just imagine that there we were trying to push a empty can or a cork inside the fluid. Okay, so the upthrust that we are experiencing will increase. Okay, more and more of the volume when it gets immersed in the water, the upthrust experienced will be increasing until it gets completely immersed inside the fluid. Okay, so larger the volume of a body submerged in a fluid, greater is the upthrust. Okay, when the volume submerged increases, upthrust also increases. Now take another case. If you are taking many feathers, okay, a bunch of feathers is taken and some hard objects, let's say a hammer or a stone is taken. Okay, both of them are released. Which will reach the ground faster? You are sure that the rock or the stone which is taken or a hammer which is taken will reach the ground faster. So here what is the reason? Here when you take feathers, what is happening? The volume is greater. Okay, we are taking not just one feather, a bunch of feathers. Volume of feathers is greater. When volume becomes greater, what happens? The upthrust, because of air, there will be an upthrust. The upthrust will be greater. Okay, the upward force will be greater. So here again, this is valid. That is, larger the volume of a body submerged in a fluid, greater is the upthrust. In the case of stone or a hammer, what is happening? The weight is very high compared to this upthrust and it will fall to ground easily. But this will take time. Okay, but this is not possible in the case of vacuum. In air, because of air, there is an upthrust. Air is a fluid. When you take vacuum, there is no fluid. Okay, which means both of the body will be reaching the ground at the same time. So this is possible. Remember, it is not possible in vacuum. Why? Because in vacuum there is no fluid. Because there is no fluid, there won't be any upward force. Okay, only gravity will be acting. Second is, for the same volume of a body inside a fluid, more the density of fluid, greater is the upthrust. Okay, consider a case, you are taking fresh water and here you can see a piece of wood which is placed on the surface of fresh water. What happens? You can see that it is floating with 50% inside and 50% outside. Now, consider that you are going to add salt to this fresh water. What happens when salt is added? When salt is added, the density of the water will increase. Okay, it has now become salt water. The density is greater than the fresh water. When the density of the fluid is increasing, what happens is, now how the body will float on the surface of liquid will be in this way. Okay, it has risen. So what has happened? Because of the increase in density, the upward force has increased. Upward force, so the upthrust that is exerted by the fluid on the body has increased. Okay, now you take two containers. One is filled with water and the second one is filled with glycerin. So we know that the density of water is less than the density of glycerin. Okay, you are taking two identical corks, okay, which are placed on the surface of the fluids. So what happens is the cork will almost be in this way in case of water, 50% inside, 50% outside. Now when you take the case of glycerin, the cork which is placed will be in this way. Okay, so here you will understand the upward force, upthrust is greater. Okay, because the upthrust is greater, the body will be floating in this way. Okay, now in order to balance it, if you want to bring 50% of this cork B inside the fluid, what should be done? You should apply an external force. Only when a force is applied, that is, I am going to push it, okay, I am going to push it down. Then what happens? Because of the force that I am exerting, what happens? The body can submerge in this way. Once I release it, once I remove that force, what happens? It comes to its original position. Okay, so what you can understand that when the density of a fluid is increasing, what happens? The upward force will increase, the upthrust will increase. Okay. Next characteristic property, the upthrust acts on the body in upward direction at the center of buoyancy, that is the center of gravity of the displaced fluid. Okay, so here when you take the case, a body, all the objects will be having a center of gravity. What is center of gravity? So here I have a pen in my hands. Only at one point when I place the finger, I will be able to balance it. Okay, so when I place the finger here and the pen is held at this point, okay, with my finger you can see that it is balanced. Okay, this point is the center of gravity of the pen. For every object there is a center of gravity. Now when an object is immersed inside liquid, a uniform body is immersed in a liquid, you will be able to see that the center of gravity G, okay, of the body will coincide with the center of buoyancy when it is fully immersed inside the liquid. Okay, so here if this was the case, the body you can see is fully immersed inside the liquid, then the center of gravity, which is represented by letter G, and center of buoyancy represented by B, will coincide. Because of center of gravity, there is a downward force, which is the weight of the buoyant force. So because of the center of buoyancy, upward forces in the upward direction. Okay, upward force or upthrust, buoyant forces in the upward direction. Now take the case when a body is partially immersed, that is, only some portion is inside the liquid, the remaining portion is outside the liquid. In that case, you will be able to see that the center of buoyancy will coincide with the center of gravity of the body, of the portion of the body that is inside the liquid. So here in this case, you can see only this much portion of the liquid is, only this much portion of the body is inside the liquid. Okay, now the center of buoyancy will not coincide with the actual center of gravity of the body, but the center of buoyancy will now coincide with the center of gravity of this much portion, only this much portion. Okay, if you take this portion is inside, so center of gravity of this portion and the center of buoyancy will coincide. Okay, but the actual center of gravity will be above the center of gravity of the portion that is immersed. It will be above that. Okay. Now what are the reasons for upthrust? So here you can see that a body is inside the water. Okay, inside the fluid. You will be able to see inside a liquid. The liquid will be exerting pressure in all directions, in the downward direction, upward direction, left, right, in every direction, the liquid will be exerting a pressure. And also we have studied the pressure exerted will be greater when it is at the bottom compared to the free surface. Okay. Now, when this body is immersed, this body will be having an area. Let's say the total area is A. Okay. Here, this is a free surface. The pressure exerted at this surface, okay, that is the upper face. Pressure P will be equal to H rho G. Density is the same. Acceleration due to gravity is same. Let's say this height is H1. Okay, it will be H1 rho G. We can call it as P1. Okay. Now, this is the bottom surface. Here the pressure exerted P2 will be equal to H2 rho G. We know that H2 is greater than H1. Pressure depends on the depth, acceleration due to gravity and the density. Okay, density of fluid. Now we have understood that From this, H2 is greater than H1, which means P2 will be greater than P1. Okay, there is a difference in pressure. So, difference in pressure is equal to P2 minus P1. Okay, we know that pressure is equal to thrust by area, from which we can calculate thrust. Upthrust will be equal to pressure into area. Okay, here in this case it is the upthrust. Upthrust is equal to pressure into area. Here what is the difference in pressure? P2 minus P1 into the area A. Okay, so the thrust F on the side walls of a body. Now when you compare, you will be able to see that here pressure is there, here also pressure is there. Okay, so because the pressure is being exerted by the fluid on the side walls as well. So here what happens is they are equal in magnitude and opposite in direction, they get cancelled out. Okay, that is not the case with the pressure that is exerted on the upper and the lower faces of the body. Clear? Now, if you are taking here, there is a difference in pressure. Because of this difference in pressure, there is an upthrust and the body will not fall easily to the bottom. It won't come easily to the bottom. Okay. Now, take a case if you are taking a thin sheet. Okay. If you are taking a thin sheet. In this thin sheet you are placing on the surface of the fluid. Okay. Here what happens is upper surface, lower surface. Okay, density and acceleration due to gravity are the same. To get pressure difference, there should be a difference in height. Here there is a negligible difference in height. H1 will approximately be equal to H2 because it is a flat thing, okay, thin sheet. In that case, what happens? The weight will be greater than the upthrust and the body will easily fall to the bottom of the container. Upthrust is equal to the weight of displaced liquid. So here consider a container that is filled up to the brim with water or any fluid. Okay. So when you put a object, what happens? You will be able to see that the water will get displaced from this container and falls to the ground. Okay. It will happen because there should be space for the object to occupy. Now, this is the case. Okay. So here you should remember one thing, that is the upthrust on the object because of the liquid will be equal to the weight of the water or the fluid that is displaced. Okay, when the object is submerged. So when half portion of this is submerged, the object is submerged in the liquid, what happens? That much volume of water will come out. Okay, it will have some weight. This weight will be equal to the upthrust that is exerted by the liquid on the object. Okay, now this is the object. Its area, let us take area is equal to A. This is the upper surface, this is the lower surface. Okay, so on the upper surface there is a pressure exerted. Yes, there will be a downward force. So here the pressure P1 will be equal to height H1, that is the depth. This surface is at H1 distance from the surface, from the free surface of the liquid. Okay, so pressure P1 will be H1 rho G. Okay, then what is the downward force? Downward force or downward thrust will be equal to, thrust is equal to pressure into area. Pressure is P1 into area A, which is equal to H1 rho G A. Okay, now what about the pressure? Okay, that is the upward pressure. So here you can see P2 is exerted on the lower surface. Okay, in the upward direction. What will be this pressure? It is acting on an area A. Okay, so P2 will be equal to, its distance from the free surface is equal to H2 rho G A. Okay, this is what P2 is. Then you will be having the upward thrust. Upward thrust is equal to P2 into A, which is equal to H2 rho G A. Okay, this force let us mention it as F1 and this is F2. Okay. Now, the difference, there is a difference in force which we can call the buoyant force. This is the upthrust or the buoyant force will be equal to F2 minus F1. What is F2? F2 is equal to H2 rho GA minus F1 is equal to H1 rho GA. Okay, here you will understand that since H2 is greater than H1, F2 will be greater than F1. Yes, because of this reason, the upward force is greater, okay, than the downward force. That is, the body will be pushed upwards more, okay, than the force that is pushing the body down. So, this is equal to H2 minus H1 into rho G into A. Okay. H2 minus H1 into A. We know that volume is equal to, what is volume? Volume of a object. Okay. Its height into the area. So, here the difference in height into area will give you the volume. Volume rho G. So, this is what FB is. Okay. So, buoyant force is equal to, what is V? V is the volume of object submerged into rho is the density into G is the acceleration due to gravity. Acceleration due to gravity. Okay, this volume of object submerged is equal to the volume of water that will get displaced. Okay, so this is equal to volume of water displaced into density of the fluid into acceleration due to gravity. Okay, now we know that density is equal to mass by volume, which means mass is equal to density into volume. Okay, so here you can say that density into volume. Here we have volume, this is density. Density into volume is mass. Okay, so mass into acceleration due to gravity, which is the weight. Therefore, this is how you are getting the buoyant force is equal to the weight. Okay, buoyant force, upward force that is exerted by the fluid on the object will be equal to the weight of the liquid that is being displaced. Okay, this is how you derive this. Okay, note this point. So, we have understood that the upthrust on an object when a body is submerged is equal to the weight of the liquid that is being displaced. Okay, if the body is completely immersed, in that case. So, here the body can be in this way, the body can be in this way, body can be like this, body can be like this, or the body can be like this. All these cases. Okay. So, if the body is completely immersed in a fluid, that is this case. Here the body is completely immersed in a fluid. The volume of liquid displaced will be equal to its own volume and upthrust then will be the maximum. Okay. Maximum upthrust will be in this case. Okay, it will be equal to the weight of the body. FB dash is equal to weight of the body. Here you can see that the volume that is inside the, that is submerged is increasing. Okay, when the volume that is submerged is increasing, the volume of water displaced, what happens? The volume of water that is displaced will also increase. Okay, in this case, the maximum water is displaced. In this case, the minimum water is displaced. Okay, when the volume of water displaced increases, we know that the weight of water that is displaced is also increasing. Okay, so this is where there is the maximum buoyancy. Okay, FB maximum is in this case, and here FB is minimum, buoyant force is minimum. Okay, although the above result is derived for a cylindrical body. So, we have taken, that is the derivation we have done with the cylindrical body. Now, consider a case you are putting a cuboid box, a box which is in the shape of a cube or a cuboid. Again, the derivation you will have to do with the cylindrical box, but the volume that you will be getting, after derivation you will be getting upthrust is equal to the weight of liquid displaced. The same thing will be, we can prove even with the body of any shape or any size. Although the above result is derived for a cylindrical body, it is equally true for a body of any shape and size. Clear? Now, what are the factors affecting the upthrust? Magnitude of upthrust on a body due to a liquid depends on the following two factors. First one, volume of body submerged in a liquid or a fluid. So, when you take two containers, okay, the first container, the body, only this much portion of the body is submerged. The other, this much portion is submerged. That is, here 1/4 is submerged and here 3/4 is submerged. That is, the volume of the body submerged is greater in this case. In which case will be the amount of water displaced greater? Amount of water displaced will also be greater in this case. Okay, because this much volume of water should be displaced. Okay, so this is greater, which means the weight is greater, weight of water displaced is greater in this case, which is equal to the upward force or the upthrust or the buoyant force. Okay, so here you will be having the volume greater, the weight of liquid displaced greater, and therefore the buoyant force is greater. That is, one factor on which the buoyant force or the upthrust depends on is the volume of body that is submerged. Volume of body submerged increases, volume of water displaced increases, the weight of the water increases, weight of the water that is displaced increases, which means weight of the water displaced is equal to the buoyant force or upthrust, therefore upthrust also increases. Okay, direct proportion there. Second is density of the liquid or fluid in which the body is submerged. Okay, this case also we have discussed. When you take the case of fresh water, in fresh water, when you put an object and when salt is added to it, that is the density of the liquid is changing. What happens? There is a change in upthrust as well. Okay, the upthrust is also changing. Effect of upthrust. Have you ever tried to lift a bucket of water from a well? If not, just try this. Okay, so take a rope, tie a bucket to it. There will be a pulley. One side of the rope, one end of the rope you are holding in your hands. Okay, then you are releasing the bucket. It is going deep inside the water. Okay, when it goes deep inside water, what happens? Water will get into the bucket will be filled with water. Now you are trying, let's say till here there is water. This is a free surface. Okay, till here there is water inside the well. Now when you try to lift, the bucket will reach here. Okay, the bucket will start from here, it will be reaching here. Okay, when you pull, it will be rising. So here what is happening, you will be able to experience one thing, that is inside the water, the weight, that is the force that you need to exert will be less. But when the bucket comes outside water, you will have to exert more force, which means the weight of the object is increasing when it comes out of water. Okay, the weight inside water will be less than the weight outside water that we feel. Okay, next, take this case. Okay, here you can see a person is fishing. The weight of the fish that he feels inside water will be less compared to the weight of the fish on the earth. Okay, in air it will be having more weight. For example, when you go to a pool, you will be able to lift a person of your same weight or a weight greater than you inside water. If the person is inside water, you can lift him. But if the person is outside water, that is, he is standing on the ground, you won't be able to lift him. You will have to exert more force. Okay, you will be tired of lifting him. But inside water, you can easily lift him. So what is the reason behind this? This is the effect of upthrust. The effect of upthrust is that the weight of body immersed in a liquid appears to be less than its actual weight. Okay, if the person's weight inside the pool, inside the water will be less than his weight. That is the weight that you feel will be less than his actual weight. The weight of the bucket will be less inside water compared to its weight outside water. The fish weight, the weight of the fish will be greater outside the water comparing it to inside the water. So this is the effect of upthrust. Archimedes Principle. Have you heard about the scientist, mathematician Archimedes? Have you heard the Eureka story? So here one day what happened is Archimedes was going to take a bath. In the bathtub he filled with water and he stepped inside the bathtub. So what happened is when he stepped inside the bathtub, the water started rising and started getting displaced. Okay, the water started falling out of the bathtub. So, what happened here? Archimedes understood that the amount of water, the volume of water that is displaced will be equal to the volume of his body that is submerged inside the liquid. So, this discovery, after this happened, he started shouting Eureka, Eureka, okay, because he has discovered something which is related to the buoyancy. Okay, so this is a Eureka story. So what does Archimedes Principle states? Archimedes Principle states that when a body is immersed partially or completely in a liquid, it experiences an upthrust, okay, which is equal to the weight of the liquid displaced by it. We have already said upthrust is equal to the weight of liquid displaced. Okay, so here when he steps inside the liquid, what is happening? There is the weight acting downward. Okay, because of this, there is a displacement of water. Okay, the reason for displacement of water is the upward force. There is upthrust which is acting on him. Okay, therefore the volume of his body submerged will be equal to the volume of water that is displaced. So this is a statement for Archimedes Principle. Archimedes Principle is not only in the case of a liquid, it is also applicable to gases. So with just a bathtub and Archimedes stepping into it experiment, we cannot prove, or there is no experimental evidence for Archimedes Principle. So here he performed two experiments for the proof of Archimedes Principle. So the first experiment is, here you can see two cylinders were taken. The first cylinder, this is a solid cylinder A, and the second cylinder B is a hollow cylinder. Okay. Then you need a physical balance. So here you can see this is how initially the first cylinder B and the second cylinder A, it was connected. Okay. Initially both of these are in air. So the physical balance will be having the left arm and right arm. So that left arm you are suspending these bodies, and right arm you are putting some masses in order to balance it. Okay, so physical balance, to balance it you are putting some weight. Now what you are going to do is you are taking a beaker D, okay, then you have a surface C. Okay, now this D beaker you are placing on C and it is filled with water. Okay, then what you are going to do is you are going to put the cylinder A completely inside this beaker D. You have to be very conscious that it doesn't touch the walls of this beaker D. Okay, then what happens? You will be able to see the water will get displaced from it. Okay, water will start coming out because the cylinder A, which is a solid cylinder, needs some space to occupy. Okay, so what happens? Then for it to occupy, water will get displaced from the beaker. Okay, then what happens? You know that inside water, we have discussed, inside water the weight of the body will be less compared to the weight of the body in air. Okay, when the weight here decreases, what happens? The left arm will rise. The left arm of the physical balance will rise because here weight is less. Okay, now what you are going to do is you are going to fill water inside the beaker, inside the cylinder B. Okay, when water is filled inside B, then this arm will start coming to its equilibrium position. Okay, so when you notice, you will be able to see that the water that is displaced from the beaker D will be equal to the water that is filled inside the cylinder B. Okay, so here when this body is immersed, it will be experiencing an upward force, buoyant force. There is upthrust. Okay, this upthrust will be equal to the weight of the liquid that is displaced. Okay, so weight of liquid that is displaced and the weight of this B when water is filled will become equal. That is, volume of water that is displaced from the beaker D will be equal to the volume of water that is filled inside B. Okay, inside B. So here what do we understand? The buoyant force and that is buoyant force or the upthrust and the water that is displaced are equal. Yes, so this is the first experiment to verify Archimedes Principle. Clear? Now here you have the second experiment. In this experiment, a solid is taken and using a spring balance, the weight of the solid is measured. Let's say it is 300 gram force. So weight of the solid in air is 300 gram force. Now what you are going to do is you are going to take a Eureka can. This is how a Eureka can looks like, and here you have a spot. Okay, till the spot. Okay, till the spot you are filling it with water. Now what you are going to do is you are going to bring this into here. Okay, that is the solid gets completely immersed inside the liquid. What happens? Water will start getting displaced. The water will move through this spot. Okay, then you are keeping a measuring cylinder in which the water gets collected. So here when you measure using the spring balance, when you measure the weight, you will be getting 200 gram force. So what has happened? We know that in the water there will be a loss in weight. So loss of weight is equal to loss of weight is equal to 100 GF. 300 GF minus 200 gram force is equal to 100 gram force. Okay. Now when you measure in this measuring cylinder, when you measure the volume of water collected, volume of water collected will be equal to 100 centimeter cube. So when it was inserted here, you will be able to see that there is an upward force acting, upthrust or buoyancy. This upward force will be equal to the volume, equal to the weight of water that is displaced. Okay, so here again Archimedes principle is proved. So when you measure, you got 100 centimeter cube. Okay, what is density of water? Density of water is equal to 1 gram per centimeter cube. We know the volume, we know the density. Then what is the mass? Mass will be equal to volume into density. Okay, that is 100 centimeter cube into 1 gram per centimeter cube, which is equal to 100. Okay, 100 grams. Okay, this 100 gram is the mass, which means weight will be equal to, weight of water will be equal to, water displaced will be equal to 100 GF, gram force. This is equal to the loss of weight, which is 100 GF. Yes. Okay. So here we understood this loss of weight will be equal to the upthrust. Yes, because of the upthrust, the loss of weight is happening. It will be equal to the upthrust, which means the upthrust, that is the force that is acting in the upward direction on the body, will be equal to the weight of water that is displaced. Again, we have proved Archimedes principle. Solid bodies with density greater than the density of liquid. So first case we'll discuss. So here you consider a body. Okay, for example, you are considering a stone. Let's say weight of stone is W, volume is V, and the density of the body is rho. Okay, then what is weight? We know that mass, volume, density relation. Volume, density is equal to mass by volume. Then mass will be equal to volume into density. So weight will be equal to, if mass is volume into density, then weight will be equal to volume into density into acceleration due to gravity. So this is the weight. Okay, weight is acting downwards. The force which is acting downwards will be equal to V rho G, where rho is the density of the object and V is the dense volume of the object. Okay, now there is an upward force. Okay, upthrust. Upthrust is represented by FB dash, maximum upthrust, which will be equal to, upthrust is equal to volume of liquid displaced into density of the liquid into acceleration due to gravity. Let us take density of this liquid is rho L. Okay, what about the volume? Volume of liquid that is displaced will be equal to the volume of object. So this volume and volume of the liquid will be equal. So V is the volume of liquid, then rho L is the density of the liquid and G is acceleration due to gravity. So upthrust FB dash is equal to V rho L G. Now the first case is when weight of the object is greater than FB dash. Okay, weight is greater than the buoyant force or upthrust. In that case, what happens? We know weight is equal to V rho G. V rho G is greater than V rho LG. V gets cancelled, G gets cancelled. So, rho is greater than rho L. Density of the object is greater than the density of liquid. Okay, when density of the object is greater than density of liquid or weight is greater than the buoyant force, in that case, the body will sink. It will not be floating. Okay, so if the density is equal to density of liquid or density is less than, density of object is less than density of liquid, the body will float. If density of the object is greater than the density of liquid, in that case the body will sink. So when you take the case of a stone, the experiment which we performed at the first starting. So we have seen that when the stone is put into water, it is sinking. It goes inside water. It reaches the bottom portion of the water. Bottom portion of the vessel. Okay. So why is it happening? Because density of stone is greater than the density of water. Understood? So this is the first case. Okay. Now in this case, you will be having a net force. What is the net force? Net force will be equal to, which one is greater here? The weight is greater. Okay. Net force will be equal to weight minus buoyant force, FB dash. Okay, W minus FB dash. If W is greater than FB dash, that is weight is greater than the buoyant force, or V rho G greater than V rho LG, or rho greater than rho L, the body will sink due to a net force W minus FB dash, which is acting downwards. You have to remember the direction. This force is acting downwards. The net force is acting downwards. Why? Because the weight is greater than the upward force FB dash. So the net force will be acting in the downward direction. Okay. Now the second case is when weight of the object is equal to the buoyant force or upthrust. If weight is equal to buoyant force or upthrust, we will be having V rho G is equal to V rho LG. Cancelling, we get rho is equal to rho L. Density of the object is equal to the density of liquid. In that case, you will be able to see that when density of the object and density of liquid are equal, in that case, the body will be floating on the surface of water in such a way it is completely immersed in the water. Okay. For example, if you are taking a glass of plain water, when you put a lemon inside, what happens? You will be able to see the lemon will sink. It will reach this point. Now, you are adding salt to this. When salt is added, what happens? The density of the water has changed. The density of the water has increased. Okay. So, when the density of the water is increasing, we know initially the density of plain water is less than the density of lemon. Because of this reason, the lemon will sink. Now, when salt is kept adding, we keep adding salt, what happens? The density of the liquid is increasing. When the density increases, slowly the lemon will start rising up. Once the density of the liquid, that is density of salt water and density of lemon becomes equal, it will start floating on the surface of water in such a way that it is completely inside water. Okay, it is completely inside water. Now, in this case, what will be the net force? Net force will be equal to, here weight and the buoyant force are equal. Therefore, net force will be equal to 0. That is, the upward force and the downward force are equal in magnitude. Therefore, the net force will be equal to 0. Now, the third case, when weight of the object is less than the buoyant force FB dash. Okay. Then V rho G less than V rho LG or rho less than rho L. Density of the object is less than the density of liquid. Okay. When density of objects becomes less than the density of liquid, what do we understand? So, in the previous two cases, we were able to see the center of gravity and the center of buoyancy were coinciding because the body was completely inside water. Now, in this case, you will be able to see a portion of the body is inside water and a portion is outside water. In that case, the center of gravity, center of buoyancy will coincide only with the center of gravity of the portion of the body that is inside the liquid. Okay. So, it is over here. This is the actual center of gravity G. Okay, this is G dash, which is the center of gravity of the portion that is inside water. Okay, now here the weight of the body is acting downwards and the buoyant force is acting in the upward direction. Which is greater? The body is floating, okay, in such a way that a portion of the body is outside the liquid, which means here the weight is less than Fb dash. Okay, then what will be the net force? Net force will be equal to Fb dash minus weight of the body. Fb dash minus weight of the body. In which direction it will be acting? Okay, now compare which one is greater. Fb dash is greater. Okay, when you have two forces of different magnitudes, then when you take the net force will be in a direction which is in the direction of the force with greater magnitude. So when you compare weight and Fb dash is having greater magnitude. Therefore, the net force will be in the upward direction. Okay, net force is in the upward direction. To conclude what we have understood, let's do an experiment. Solid bodies experiment. So here in a tumbler, water is taken, two objects are taken, one is an iron nail and the other one is a cork. So first when you drop iron nail, what happens? The iron nail will sink. It will come to the bottom portion of the tumbler. Okay, when the cork is kept, the cork will start floating on it. Okay, 2/5 of the cork will be inside and 3/5 will be outside. So here what do we understand? We understand that the density of iron nail is greater than density of water. Only because of this reason, iron nail sinks. Okay. What about the case of cork? The density of cork is less than the density of water. Because of this reason, the cork will be floating. So when you compare, you will understand the density of iron is greater than density of water, which is greater than density of cork. Okay, so this is the thing. This is what happens when you compare the densities. Now, when you take different objects, for example, you have a bowl, then paper sheet, next a toothpick, a bangle, a stone. Okay, when you have different objects, you try placing these objects on the surface of water. You will be able to see that some objects will sink, some objects will float, some objects will float in such a way that it is completely inside. The entire portion of the body is inside the liquid. Okay, so there will be differences. This all depends on the density. An object with greater density of the object, if it is greater than the density of liquid, it will sink. If the density of the object is less than the density of the liquid, then it will float. Even when they are equal, they will float in such a way that the body is inside the liquid. Let us take an example. A body weighs 200 gram force in air and 190 gram force when completely immersed in water. Calculate the loss in weight of the body in water and the upthrust on the body. So first we will calculate the loss in weight. Weight in air is given. Weight in air is equal to 200 gram force. Next, weight when completely immersed in water, that is weight in water is equal to 190 gram force. So then what is the loss of weight? Loss of weight is equal to 200 gram force minus 190 gram force, which is equal to 10 gram force. Okay, this is the loss of weight. Okay, so here the answer is 10 gram force. Next, the second part of the question, the upthrust. So we know that the upthrust on the body, upthrust according to Archimedes principle, upthrust on the body is equal to loss of weight of body in water. Okay, which is equal to 10 gram force. Upthrust on the body is equal to 10 gram force. Second example, a piece of iron of density 7.8 into 10 raised to 3 kilogram per meter cube and volume 100 centimeter cube is completely immersed in water of density 1000 kilogram per meter cube. Calculate the weight of iron piece in air, the upthrust and its apparent weight in water. Okay, so first we will calculate the weight of iron piece in air. Okay, what is given? Density of iron is given. Density of iron piece is equal to 7.8 into 10 raised to 3 kilogram per meter cube. What else is given? Volume is given. Volume is equal to 100 centimeter cube. We know 1 meter is equal to 100 centimeter, which means 1 centimeter is 1 by 100 meters. Okay. Now, here we have 1 centimeter cube will be equal to 1 by 100 cube meter cube. That is 10 raised to minus 2 cube meter cube, which is 10 raised to minus 6 meter cube. Okay, so this is equal to, if 1 centimeter cube is equal to 10 raised to minus 6 meter cube, then 100 centimeter cube will be equal to 100 into 10 raised to minus 6 meter cube, that is 10 raised to minus 4 meter cube. Okay, so this is 10 raised to minus 4 meter cube. This is the volume. We have to find the weight. What is weight? We know mass is equal to density into volume. Here what is density? 7.8 into 10 raised to 3 kilogram per meter cube into volume is equal to 10 raised to minus 4 meter cube. Okay, this is mass. Then what about weight? Weight is equal to mass into acceleration due to gravity. Here acceleration due to gravity is 10 meter per second square. Therefore, 7.8 into 10 raised to 3 into 10 raised to minus 4 into 10. Okay, this is equal to 7.8 into 10 raised to 3 into 10 is 10 raised to 4. 10 raised to 4 into 10 raised to minus 4 gets cancelled. Then you have 7.8 Newton. So, this is the weight. Now, the second part of the question, we have to find what is the upthrust. How to find upthrust? What is upthrust? Upthrust will be equal to V rho G. That is volume of water displaced, density of water and acceleration due to gravity. Here volume of water displaced is 10 raised to minus 4 meter cube. Why? Because the volume of iron that is submerged will be equal to the volume of water that is displaced, therefore 10 raised to minus 4 meter cube. Then what is rho? Rho is the density. Density of water is given, which is 1000 kilogram per meter cube. Acceleration due to gravity is 10. So, how much do we get? This is 10 raised to minus 4 into 1000 into 10 is 10 raised to 4, which is equal to 1 Newton. Okay, this is unit is meter per second square. 1 Newton, 1 kilogram meter per second square or 1 Newton. 1 Newton is the upthrust. Next we have to find its apparent weight in water. How to find the apparent weight? Apparent weight will be equal to, apparent weight will be equal to, so we know how to find the upthrust. Upthrust will be equal to the loss in weight, that is weight in air divided, weight in air minus weight in water. So, we have to find the weight in water. Weight in water will be equal to weight in air minus upthrust. Okay. So, weight in air. What is the weight in air? 7.8 newtons minus 1 Newton, which is equal to 6.8 Newton. 6.8 Newton is the apparent weight. Third example, a solid of density rho has a weight W. Show that its apparent weight will be W into 1 minus rho L by rho when it is completely immersed in a liquid of density rho L. So, density of the solid is rho and the density of liquid is rho L. Okay. So, here we know that density is equal to mass by volume. Okay, from which we can say volume will be equal to mass by density. Mass by density. We have weight is equal to mass into acceleration due to gravity. Then what is mass? Mass will be equal to weight divided by acceleration due to gravity. So this is a weight. Okay, weight at the actual weight divided by acceleration due to gravity, you will get the mass. Then what is volume? Volume will be equal to, that is here we are finding the volume of solid. Volume of solid will be equal to mass by density. Here mass is W by G divided by density is rho, density of the solid. So here we got volume of solid. So when it is immersed in a liquid, what happens? Volume of solid is W by G divided by rho. So what will be the volume of liquid that is displaced? The volume of liquid displaced will be equal to the volume of solid, that is W by G whole divided by rho. Okay. Now, how to find upthrust on the object? Upthrust will be equal to volume of the liquid displaced, volume of liquid displaced into density of liquid into acceleration due to gravity, which is equal to volume of liquid displaced. What is the volume of liquid displaced? Here we have W by G divided by rho. Okay. Then density of the liquid. Density of liquid is given rho L. Acceleration due to gravity is G. Okay. So this can be written as W by G rho into rho L into G. G gets cancelled. Then you are having W rho L divided by rho. This is the upthrust. Okay. We have to show that apparent weight will be W into 1 minus rho L by rho. We have upthrust is equal to actual weight minus apparent weight. Actual weight minus apparent weight. Okay. So here we have to find the apparent weight. Apparent weight is the weight in a liquid and actual weight is the weight in air. Okay. So apparent weight will be equal to, apparent weight is equal to actual weight minus upthrust. Okay, what is the actual weight? Actual weight is W minus what is the upthrust? W rho L divided by rho, which is equal to, W is common, taking out 1 minus rho L divided by rho. So here we have got the apparent weight is equal to W into 1 minus rho L divided by rho. Now let us solve problems from exercise 5A. Question 1 of exercise 5A, a body of volume 100 cm cube weighs 5 kg force in air. It is completely immersed in a liquid of density 1.8 into 10 raised to 3 kg per meter cube. First question, find the upthrust due to liquid. Second, the weight of the body in liquid. So to find upthrust, here what is given? We are given the volume of the body equal to 100 cm cube. We know 1 cm cube is equal to 10 raised to minus 6 meter cube. Then what is 100 cm cube? 100 cm cube will be equal to 10 raised to minus 4 meter cube. What else is given? Weight is given to be equal to 5 kgf. It is completely immersed in liquid of density. Liquid density rho L is given, which is equal to 1.8 into 10 raised to 3 kilogram per meter cube. So first thing we have to find is upthrust. How to find upthrust? Upthrust due to the liquid will be equal to volume of liquid displaced into density of the liquid into acceleration due to gravity. So here what is the volume of liquid displaced? Volume of liquid that is displaced will be equal to the volume of object. Yes, when an object is submerged in water, what happens? That much quantity, that much volume of water will get displaced. Okay, so this is equal to 10 raised to minus 4 into density of the liquid is given 1.8 into 10 raised to 3. Then acceleration due to gravity g. Because here the unit is kilogram force. So you can keep g as it is. This is equal to 0.18 g. That is 0.18 g means it is, you know the relation, 1 kilogram force is equal to 9.8 Newton. Okay, so here we have 0.18 g. So this is equal to 0.18 kilogram force. 0.18 kilogram force is the upthrust. Now second thing to find is the weight of the body in liquid. To find the weight of the body in liquid means we are going to find the apparent weight. Apparent weight is equal to true weight minus upthrust. So here what is the true weight? 5 kilogram force minus 0.18 kilogram force, which is equal to 4.82 kilogram force. So this is the apparent weight or the weight of the liquid, weight of the body inside the liquid. Question 4 of exercise 5A, a solid of density 5000 kg per meter cube weighs 0.5 kg force in air. It is completely immersed in water of density 1000 kg per meter cube. Calculate the apparent weight of solid in water. To find the apparent weight, what do we need? Apparent weight is equal to true weight or actual weight minus upthrust. Okay, do we know the true weight? True weight is given, W is equal to 0.5 kgf. Do we know the upthrust? Here a solid of density of the solid is given, rho is equal to 5000 kilogram per meter cube. Okay, then what else is given? Weight is given. It is completely immersed in water of density. Density of the liquid is given to be equal to 1000 kilogram per meter cube. Calculate the apparent weight. Okay, now we have to find the upthrust. To find the upthrust, what do we need? Upthrust is equal to, we know upthrust is equal to volume of liquid into rho L into acceleration due to gravity g. So here in this case, you are able to see that we know the value of rho L. What is the volume? Volume of the liquid that is displaced will be equal to the volume of the object. Now how to find the volume of object? So we have relations, weight is equal to m into g. Okay, we know the value of weight. Okay, what about density? Density is equal to mass by volume. From this we will be having mass is equal to W by G. Okay, mass is equal to W by G. So this is equal to W by Vg. Here we need volume. Okay, so if rho is equal to W by Vg, then V is equal to W by rho G. Okay, so substituting we get W by rho G into rho L into G. G gets cancelled. Okay, this the volume of the object will be equal to the volume of liquid. Only because of that we are able to substitute in this place. Okay, now what is the weight? 0.5 kilogram force into density of the liquid. Density of liquid is 1000 kilogram per meter cube. Then what else? Density of the object, which is 5000 kilogram per meter cube. Okay, so zeros can be cancelled. 0.5 kilogram force divided by 5, which is equal to 0.1 kilogram force. So this is the upthrust. You got the value of upthrust. Now we can find what the apparent weight is. So apparent weight, let's say W dash will be equal to true weight W minus upthrust FB dash. That is equal to, what is the true weight? Here the true weight is given to be 0.5 kilogram force minus upthrust we have found 0.1 kilogram force, which is equal to 0.4 kilogram force. So this is the apparent weight in the liquid. Question number 9 of exercise 5A. A block of wood is floating on water with its dimensions 50 cm into 50 cm into 50 cm inside water. Calculate the buoyant force acting on the block. Take G is equal to 9.8 Newton per kilogram. Okay. So here we are given the dimension. From dimension we can find volume. 50 centimeters into 50 centimeters into 50 centimeters. Okay, 5 into 5, 25, 25 into 5, 125. Then 3 zeros, centimeter cube. Okay, centimeter cube, meter cube conversions. So 1 centimeter cube is equal to 10 raised to minus 6 meter cube. Okay. So here 10 raised to minus 6 meter cube means 1, 2, 3, 4, 5, 6. You will get 0.125 meter cube is the volume. Okay. Next, what is the density? Density of water is 1000 kilogram per meter cube. Acceleration due to gravity is given. G is equal to 9.8 Newton per kilogram. Okay. So here we are asked to find the buoyant force. Buoyant force means we have to find the upthrust, which is equal to volume of liquid displaced into density of the liquid into acceleration due to gravity. The volume of liquid displaced will be same as the volume of the block, that is 0.125 into 1000 into 9.8. So when you calculate this, you will be getting 1225 unit is Newton. Okay. So upthrust is equal to 1225 newtons. That's all for today. In today's class, we have discussed about upthrust, buoyancy, Archimedes Principle, and also solve questions from exercise 5A. Hope you all enjoyed this session. I'll be back in the next session. Until then, stay tuned to Learnohub. Learnohub free hai, par best hai. Thank you.